Alright, so we're going to talk about the derivative of a to the x. A to the x means just any number to the x. So on the first page, we just have some review about rules. We got the power rule, we got the chain rule, some things we might have to consider here. Let's go to the next page. So, I'm going to show you a quick little proof as to what the derivative of a to the x is. Here's the rule for it. When you take the derivative, it ends up being just the natural log of whatever your base is times a to the x, and then of course times du or dx if you have to apply the chain rule. But you're going to want a little blank piece of paper somewhere. Maybe it's in the margin, maybe it's just up here, maybe it's a whole other piece of paper, but let's just show you why. This is going to be really helpful for you to use when you're having to kind of recreate this rule. So let's say you just start with y equals some number a to the x. You can't differentiate this as it is. But what you can do is you can take the natural log of both sides. And if you do that, you'd have the natural log of a, and instead of to the x, you can move the x out front. And now really what you're looking at is the natural log of y equals x times a coefficient of ln of a. This is just a number, remember? So this is just a coefficient. What we're going to do is we're going to take the derivative implicitly. This means, so you've done this before, you just didn't really know it. It means I'm going to do chain rule with the dy and the dx on both of these. So here we go. The derivative of ln y, we know the derivative of the ln of a function is just 1 over y times dy. And the derivative of x is just its coefficient, which is just ln a. So I'm just going to write ln a, and then I'm going to say dx. Now, I'm going to divide the dx on both sides so that that cancels. I'm also going to multiply y on both sides so that that cancels. And so I'm left with dy over dx equals the natural log of a times, should have completed my parentheses here, times y. Well, this is a little confusing because we have it in terms of y, but don't we know what y is? Isn't y just a to the x? So this is really the natural log of a times a to the x. And you can put it in parentheses if you want. And that's it. Of course, if x is a function, then you're going to have to times it by the derivative of x, or derivative of u, or whatever it is you're using. And you'll notice that is the formula we got here, the natural log of a times a to the x. So really it's the same thing, just times the natural log of it. Natural log of the base, that's it. So let's practice in a couple here. Y equals 2x. Should be pretty easy, right? The derivative is just going to be y equals the natural log of 2 times 2 to the x. And that's it. That's it. Once you try part B here on your own, I think you could do it pretty quickly. Give it a shot. Yeah, hopefully you saw this is just the natural log of 3 times 3 to the x. There you go. Okay, let's look at example 2 on the next page. Okay, so now we actually have a function inside a function. So let's make u equal 3t. And therefore my du is going to equal 3. And so we can rewrite this as f of t. I haven't taken the derivative yet. This is just 2 to the u now. Therefore, f prime of t equals the natural log of 2 times 2 to the u times du, because we are using the chain rule here. Okay, let's plug it all back in. This is simply the natural log of 2 to the 3t times 3. Put it all in parentheses just because it gets a little confusing otherwise. You don't have to, it just seems more organized when I do, for me, when I do that. Okay, on the next one, again, I want to encourage you guys to try this on your own and then just check back when you're ready to check your answers. Alright, so hopefully you saw that even though this is a function inside of a function, the derivative of the inside here is just going to be 1, because it's just 1t and that's just a constant. So So we don't really have to concern ourselves with the chain rule here. So the derivative of t here, or f of t here, would be the natural log of 3 times 3 to the t minus 1. That's it. Alright. Got a lot more interesting one going on down here. 2 to the x squared. Well, let's go ahead and substitute in a u for our x squared, making our du be 2x. And that means that y is really 2 to the u. This is easy, right? Y prime now is going to be the natural log of 2 times 2 to the u times du. Alright, so the natural log of 2, this is really 2 to the x squared, and my du is really 2x. Now, I want to show you something about how you can organize this answer that you probably are going to understand, but you probably just have never seen before. Let's think about this. First of all, I have an x and I have an ln2. Alright, I'm going to just take this x, this ln2, I'm going to put it out in front. So this is like x times the ln of 2. I'm still left with this 2 to the x squared and then this 2. And this 2 here is really like 2 to the 1. And so when you're multiplying two things with the same base, you can just add the exponents. And so what I think you're going to see sometimes is something like this, and then you're going to see the 2x squared plus 1. And so they've combined these two 2's to have, since they have the same base, as just one base with x squared plus 1 as the exponent. Alright, let's go to the next page. Okay, so this one's kind of interesting. We're going to eventually have a rule for logarithms, but it comes from this same idea. So we're going to use the natural log and the same rule, but before we do that, let's rewrite this then. Since this is really just, a logarithm is just an exponent rewritten, let's rewrite it as that exponent. The 10 is the base, so it'd be 10 to the y equals 2x. Alright, well that's pretty doable, right? So let's just do this, like I said before, kind of implicitly, which means we're going to just kind of take the derivative of this and this separately with the dy's and the dx's at the end. Let's see what happens. Remember, this is just like a to the x, only now it's 10 to the y. So what would that derivative be? Well, it would be the natural log of 10 times 10 to the y. But now we're going to slap that dy on the end. Okay. And what would the derivative of 2x be? Well, it would just be 2 and then dx. Well, hopefully you see what we can do here. We can divide the dx on both sides. And we can divide this ln 10 and 10y, 10 to the y, on the both sides. Okay, so these guys are gone and all of these guys are gone. And so let's rewrite what we have. I'm just going to write it over here. This would be like saying a 2 over the natural log of 10 times 10 to the y. Okay, so here's the deal though. We don't want it in terms of y, we want it in terms of x. And so what we really have here, and this is where it gets kind of funky, is we really have 2 over the natural log of 10 times 10 to the, what was y originally? It was the log 10 of 2x. Well, now if you remember your log and exponent properties, this is really just 2x. But let's show you why, okay? A little bit more just kind of playing with these numbers. Let's go up here and let's just say, hey, let's say I had the 10 of log base 10, or 10 to the power of log base 10, 2x. And let's just set that equal to some random thing. Let's just say it's equal to p for now. Okay, let's play with this. If I was to put this in logarithm form, my base would be 10, And then I would write it like this. I would write it as log base 10, because this is my base, drop my base, and then I would switch these two things. So it would be log base 10 of p equals log base 10 of 2x. And so you should be able to see here, look, everything is the same except for the p and the 2x. So really, this whole thing, if it equals p, well, p has to be the same thing as 2x, so this whole thing just equals 2x. Okay, so we go back to our derivative here. We're almost done. It's going to equal 2 over the natural log of 10 times 2x. And I guess theoretically these x's could cancel out, and so we are finally left with, this is all equal, so this I can write it up here as well, 1 over x natural log 10. I just put the x in the front. Okay, now again, like I said, we're going to find a rule for that on the next video, but I just thought I'd show you kind of how we can use the rules for a to the x derivative to find the derivative of this guy. Pretty nasty problem. Okay, there's 2 more here. I think you guys can try those ones on your own. Pause the video, give it a shot, and then just unpause it when you're ready to check your work. Alright, the first one may seem tricky, but it's really not. Remember, pi is just a number. It's just a constant. So this is just the natural log of pi times pi to the x. That's it. This guy, a little bit tricky. Not really, though. You just got to remember, hey, this is technically a function inside a function. There is a derivative of negative x. It's just -1, but it still warrants a little mini chain rule. So if we go ahead and do that, we could substitute in a u. We get y equals 3 to the u equals -x, therefore du equals -1. Okay, so the derivative of 3 to u, that's easy. It's natural log of 3 times 3 to the u times du. Plug our u's back in, our du's. So I put the natural log of 3 on top because it is being on top. It's multiplied with a negative out in front. And this negative exponent just means that we're dividing. So there's our derivative. Alright guys, see you guys on the next video.